know I hear some of you guys singing along to the chime. Okay. So I need everybody on this page, everybody looking at the guided practice, and facing toward your paper, please. Pencils in hand. Let's go through the guided practice together. Then we will stop. We'll do some independent work. And then we'll come back around and we'll go through everything, okay? So, I think you guys are probably pretty comfortable with this. Yes? Thumbs up? Feel pretty comfortable with it? Yeah? Good.
Kindergarten.
Oh, I don't know about that. I'm sure you wouldn't have felt that way in kindergarten. Okay. Now, let's look at the first question. How can fraction strips help you reason about size to find whether 4/6 or 4/8 of the same whole, it's important, same whole, is greater? This is something that has to be, this is a written answer. So how? How can we use fraction strips? Who wants to tell me? How can we do it? Ian?
We can take a whole fraction strip and cut it up.
That's right. We can. We can take a whole fraction strip. We can take two of them. Right? And we can cut up 1 into 6 and 1 into 8, right? And then we can color them in. Now, my drawing may not be perfect, but what is 4/8 equivalent to? What's 4/8 equivalent to, guys? Look at that number. Ariana? It's 1/2. Now 4/6 is not 1/2. It's greater than 1/2, correct? So, which one of those is greater? 4/6 or 4/8? Which is greater? Which is greater? Talon, what do you think? 4/6 or 4/8?
4/6.
That's right. But all you have to do is look at the drawing, right? Which one looks like it has more colored in? This one is greater. Which one looks like it has more colored in, right? And yes, it does count which one has less as well. But good. Good. So this makes sense, right, guys? Thumbs up?
Kindergarten.
Good. Okay. As we keep saying, it's kindergarten work. That means I should have no questions from you on it, right? Okay, let's take a look at number 2. Which is greater? 1/4 or 1/6? Draw fraction strips to complete the diagram. Now, in this question, we've talked about this before. If you get down to an area where they're there, you know automatically, that's what's important to me. However, this problem says specifically to draw fraction strips. So if you haven't done it and you have a problem that tells you to draw them, then I can't count that as done. You need to do what it asks you to do in the directions. So it says draw fraction strips to complete the diagram and answer the question. We're looking at which is greater, 1/4 or 1/6. So in this case, we're going to use strips the way they do, not the full bar cut up, right? We're going to do it like this. We're going to go 1. Well, let's do this a little bit better. I'll try to, whoa.
Why don't we just erase it?
I don't want to delete the entire thing. Aston, please stop calling out. Yes, I can erase it. However, because I'm doing it differently, it's a little bit different. Okay. So, let's look at this one. 1, we're looking for what it would look like if it was cut into 4ths, right? It should be 1, 2, 3. So in that case, we should have 1/4 right here, right? Now, 1/6. So then that would change things, right? Instead of cut into 4ths, we need to change it. Cut into 6. 1, 2, 3, 4, 5. And in that case, we'll draw our 1/6 underneath the 1/4. Which one's greater? 1/4 or 1/6? Which one looks greater, guys? Which one?
1/4.
1/4. 1/4 is greater. That's right. Because 1/6, that denominator tells us we've cut the whole up into more parts, right? And those parts are going to be smaller. And it would just keep going on and on and on in that direction, right? The more we cut it up into smaller and smaller parts. Does that make sense? Thumbs up? I think you guys are really good at this. I think we're heading on the right path here. Schmidt, question.
You know how you've been doing it? And on the do you know how? Can we do it like how they do before diagram?
Well, let me see if we can get to the do you know how. We're not there yet.
Well, but
We're still in the guided practice.
can we do that? Diagram, whatever it is?
Are you talking about this section right here?
Yeah.
That's what we just did right there.
How can we draw one?
What?
1/4 and 1/6. Just one. Not like six. With boxes and four.
I think I'm not entirely sure what you're asking. Because we're looking at, this is our hole. The strips are these little things down here, right? The hole, we can cut the hole, we can do it like this as well. Where we take the hole, draw the lines through it. Or you can just draw the parts like they did. And those correspond to breaking it up, right? Because if we were to draw a line here and continue this, it would be like that. And each one of those would be 1/6, right? So in this case it says, write, again, our greater than, less than, or equal to symbols, and use fraction strips to help. In this case, we've got the hole. Remember, these are all the same hole. They're just cut up differently. So in this case, we have one that's cut into sixths and one that's cut into thirds. Andrew, which one's greater? 3/6 or 1/3? Or excuse me, 3/3. That's right. So 3/3. Look at the picture, guys. What's 3/3 equivalent to? What's 3/3 equivalent to? That's right. Now what about 3/6? There are 3 1/6 here. What are 3/6 equivalent to? Allie? 1/2. So as you can see it right here. And on number 4, Allie, what? Which one is greater, 4/8 or 4/6? Oops, I went too far. What is it, 4/8 or 4/6? 4/6, and you can see it, right? Look how much longer it is. It's a lot closer to one whole than 4/8, correct? So that is right. 4/6 is greater. Now again, we've done a lot of this kind of stuff already, so I hope you guys are feeling pretty comfortable with it. Thumbs up if you feel pretty good about this. Good. Sideways thumbs if you're getting there. That means you don't get it at all. And then yes, I know. You do good. So you like it and you can do it. Good. Good. Yeah, I think it's telling me he likes it, but excuse me, he can do it, but he doesn't like it. It's easy. That's what Heston says too. That's why he's got 2 thumbs up now. Okay, good. Briggs, give me a foot too. I'm gonna take that as a good sign. Okay, so here's what we're gonna do. You are going to work on the independent practice right here. And again, guys, you know what you're doing here, but it also says to use or draw fraction strips to help. Down here, if you need to draw them out, please do. If you do not, that's fine, but I still want to see the right answers. So use the fraction strips to help you, okay? Or models or whatever works. If you want to draw circles, okay. Now, it does say to do fraction strips, so that's what will work. But I want you guys to get the answers the way that works the best for you, okay? And your question. Okay, hold on, guys. So independent practice, I want you guys to finish up on that. I know some of you have already worked on it. Now, I also have the homework and practice page that's right here. You're going to work on that one as well. Now, guys, again, listen, everybody, because last time I got a lot of questions on it, and I keep explaining it. Yes, good, Briggs. The another look section, you need to read it. There's no work you actually have to do there. Another look just means this is a reminder to you of how to do it, right? But these things, like what he says right here, We're going to call that guy Heston's brother. He's got the red hair too. You can use fraction strips to represent and compare fractions with the same numerator. The 1/3 strip represents a greater part of the whole. The stuff he's saying is important. So read through that if you can't remember what we did on the other page, okay? Now, and read through it anyway, because you get that. The more you read it, the more you remember it. So then you'll do these right here, and I do have the back page of the homework, okay? Now I know these are going to be a little bit more challenging. I still want you to try them. But your first two ones here, independent practice, homework practice pages, the first two are your priorities, okay? Make sure you do those before you try to do this back page. And then we will come back together and we'll go through everything. But I want to see where on everyone's pages we'll make our way around. But there shouldn't be anybody who waits until the very end and then copies down the answers, okay? Because that's not how this works. We review it so that we make sure that you guys understand it, not so that you copy down answers. That doesn't help you at all. Andrew. Good. Now, who already did the independent practice section? Okay, so some of you have done it. Who started the homework practice?
I'm done.
Good. Did you do the back page too?
No, I'm starting.
Okay, good. Okay, so let's go ahead and work on this for a little while. We will come back in maybe about, let's see. Maybe about 5 or 10 after 9. We'll just see where you guys are. Okay? And everybody should be back on this page right here. Back on this page right here. As soon as Aiden gets back. Okay, is everybody back on this page? Computers aside. What's going on back there? Okay. Get these packets back out. Let's go back to this page, the one with the date at the top of it. We'll go through this one and the homework and practice page pretty quickly, and then we'll talk a little bit more about that back page. I know you guys don't like that I make you do those higher order thinking ones, but they're good practice. Makes your mind work, and I think we need a little more practice with our word problems and our multiple step problems. Okay? So there are reasons why we do this. That's a question. Can you what? Yes, go ahead. I have a question. Good, I'm glad you thought so. Okay, so everybody, let's focus on this for a minute. And let's go over and make sure everybody got the right answers here. So on number 5, we have 2/3 and 2/4. Now, I want everybody to take a look at this because I had some questions about the fraction strips. I think we still have a little bit of confusion. One more time. Wilkins, what is the denominator? Let's look at this one right here. For the first one right here, what's the denominator? On number 5, what's our denominator? For the first one. You said 4? What does it stand for? What does it mean? Not area. How many what? How many parts there are in our whole? So this is the whole right here, guys. 1/4, the 4, the denominator, is how many parts you're cutting the whole into. So if we were going to continue this drawing right here, that's a very bad. We would do another line here, and it would be 1/4 here and 1/4 here as well. Because there'd be 4 parts that we just cut that whole into. Okay? Do you see that? Wilkins, do you see how there are 4 parts for that one? Now for this one, the denominator is 3. That means that there are going to be 3 parts in the whole total. But the numerator, guys, the numerator, Briggs, what does the numerator stand for? How many you're taking out or how many you're representing, right? So in this case, the reason I didn't write 1/4 in here and 1/4 in here or 1/3 in there is because those parts, we're not using those parts right now. we're only using the parts that are mentioned down here, 2/3 and 2/4, right? They have different denominators, meaning there are different parts out of the whole, but they have the same numerator. But you can see in the picture that which one is greater? Which one's greater? 2/3 or 2/4? Which one's greater?
2/3.
That's right. And you can see it right here. It's longer, right? And on this one, there's a big blank spot here, which obviously means they want you to draw the fraction strips in. So let's do that. We've got 4/4 and 4/6. Now that means that I like to draw the whole thing, because otherwise my drawings are even worse. So I drew them out to be the same length as this, because we were looking for one whole, right? In this case, one of them has 4 parts, and that's our 4/4, and the other one has 6. Okay? So, in this one, I should have 1/4, 1/4, 1/4, and 1/4. Now, why did I write in all of the fourths on the first one? Why did I write in all those fourths? Savva? That's exactly right. Because 1/4 plus 1/4 plus 1/4 plus 1/4 equals 4/4, right? And 4/4 is also equivalent to what, guys? Equivalent to what? That's right. And you can tell because it comes right down to the end. Now, what about this one? 1/6, 1/6, 1/6, and 1/6. I'm not going to write in the other ones because we have how many 6? How many 6 do we need for this problem? Shrit? We're on 6. I'm asking you. We're on 6. That should be obvious because we already covered 1/4, and I just asked you how many parts we need.
And
4/6. So we have 4 1/6 because 1/6 plus 1/6 plus 1/6 plus 1/6 equals 4/6, right? Yeah. Yes, go ahead. So in this case, which is greater? 4/4, which we know is 1 whole, or 4/6? Guys?
4/4.
Say it again.
4/4.
That's right. Because 1 whole is obviously going to be greater, right? The other one, you only have parts. This one, you actually have the entire thing. Okay, now, let's do these kind of quickly here. For number 7, which is greater, 2/3 or 2? 2. 2 out of 2. Which one's greater?
1, 2, 2, 1
Which
whole.
is the same thing as?
1 whole.
That's right. Next one, 4/8 or 4/8? Equal. And 4/8 is equivalent to? 1/2. That's right, 1/2. Because 4 is what? 8?
A half.
That's right, 4 is half of 8. Okay, 5/6 and 5/8, guys.
5/6.
Good. 1/4 and 1/3.
1/3.
Good. 1/3 and 1/6.
1/3.
4/6 and 4/6.
Equal.
Good. 1/8 and 1/2.
1/2.
2/6 and 2/3.
2/3.
Good. Good. Everybody get those? Thumbs up? Good. Now let's take a look at this one. So again, in the another look section, it's just a reminder, but you really do need to read these because it is helpful. And I noticed some of you are still a little bit confused on what the denominator and the numerator stand for. Okay? It's really important to remember what those are because those are the basis of everything in fractions. So, when you're comparing, we're looking here at these. These are the same numerator. These have the same numerator. 1/3 and 1/4. They've got the same numerator. It's one on top. That does not mean that they are the same though, right? They have different denominators. That's the number at the bottom. That means, in the picture, look at the picture, that the one whole, this is here, up here, because it represents what we're talking about. The other two have the same whole. They're parts out of the same whole. So if you were to continue drawing this out, right, that's how you should look at this. If you continue drawing it out, they would come to the same side. They'd be the same length, the same size total, but cut up differently. Right? But the reason we don't draw those in is because we're not using those parts. This is to give you a visual that we're only using the parts that are there. The numerator is the parts, the numerator stands for the parts that we're using. So the parts that are represented, or the parts that we're taking away, right? The parts we're using. Hey, everybody, I need everybody focused, looking at your paper or up here. Not looking down at whatever's in any of your hands. You got things in your hands, set them aside. Okay? I need to make sure we're all on the same page here. So, you can use fraction strips to represent and compare fractions, right? We already talked about that. We've used them. So, let's take a look at these then. First one, number 1. We've got the picture. There's a reason we have the 3/4 there, right? The 3 1/4, because it says 3/4. There's a reason we have 3 1/8, because it says 3/8, right? Which one is greater, 3/8 or 3/4?
3/4.
That's right, and you can see it visually. Look at how much bigger this one is. Now, this one, same thing. Same thing. Got them drawn out. 2 6, 2 8. Which one's greater? It's 2 6. Now, guys, are you noticing a pattern? Are you noticing a pattern? Are you guys seeing something with those denominator sellers?
That the pattern is no matter what, the lower the denominator will always be greater because it doesn't take as many to fill.
So, he's on to something here. In this case, but this happens only when we have the same, not always only when, but it happens every time we have the same numerator and different denominators, okay? When we have the same numerator, that's the top number, and different denominators, every single one of these, the smaller denominator will have the greater fraction, right? Because we have the same numerator. If we had a different numerator, it might be different. Because if I said I had 4/8 and 2 6, then it would change the whole picture, right? In that way, we would have different numerators and different denominators, and then you'd have to look at the entire fraction, right? But Savvas is right. When we have the same numerator, the denominator, the smaller denominator, will be the greater fraction. Our parts are bigger, right? You guys see that? Does that make sense? Thumbs up? Good. Okay, what about now, they did have us wanted the drawing pictures on these. That's why you got those big blank spots here. We have 4 6 and 4 6. So the goal here was, again, you want to cut the whole up. And I'm drawing out 2 more because it's easier for me that way. But we're going to cut it up. How many parts do I need to cut both of those into, Wilkins?
6.
That's right, 6 parts. Because the denominator is 6. That means both of these, in this case, we have the same numerator and the same denominator, right? So in this case, then I need 1 6, 1 6, 1 6, and 1 6, 1 6, 1 6, 1 6, and 1 6. Now, you guys already knew looking at that one what it was, right? Because it's what?
Equal to.
They're equal. Exactly. It's the same. It's the same. But I need to know that you guys know how to use the fractions to draw it out. Because that helps give you, again, a visual of what the denominator and the numerator are, what they represent, right? So what about in this case, though? We have 2/8 and 2/3. So again, I would draw out 2 more holes under this one that look the same, ideally. Now, first fraction, we'll do the top one. How many parts do we need to cut that into, Ariana? 8. That's right. Now, for the next one, what do I need to cut that into, Abigail? How many parts do I need to cut that into?
3.
3. That's right. Now, Andrew, how many times do I need to write 1/8 in the top one? Twice. That's right, because 1/8 plus 1/8 is 2/8, right? So the rest of those don't even matter. Now, what about the bottom one? How many times, Tava, am I writing 1/3? That's right. Exactly. Because 1/3 plus 1/3 equals 2/3. So now, which is greater? 2/3 or 2/8?
2/3.
That's right. Do the fraction strips make a little more sense? Do they help some of you understand what the denominator means? No? You don't like the fraction strips?
I do.
Some of you like the fraction strips, some of you don't like the fraction strips. What I want them to do is to be able to show you guys, again, what the numerator means, what the denominator means, okay? Just always remember that bottom of the denominator, that is the number of parts in your whole. That's why I always use the pizza example. No, don't talk about pizza. You're going to have pizza today. Okay. Which is greater, 2/3 or 2/4?
2/3.
That's right. What is 2/4 equivalent to?
1/2.
That's right. Because half of 4 is what?
2.
That's right. 1/8 or 1/4, which is greater?
1/4.
3/6 and 3/6.
Equal.
1/2 and 1/3.
1/2.
4/6 and 4/4.
1/4.
Yes, 4/4 is what?
1/4.
That's right. 2/3 and 2/6. 3/4 and 3/4.
Equal.
Good. 6/8 and 6/6.
6/6.
Which is what?
1/4.
That's right. Okay, next page. Let's take a look. I know some of you guys are not liking this. I think some of it has to do with the being word problems, which is why it's really important to pay very close attention. Slow down. Read it carefully. Okay? Take your time on these. Ivan played basketball for 2/3 of an hour on Tuesday and 2/4 of an hour on Wednesday. Which day did he spend the most time playing basketball? Use the symbols to compare. Write each fraction and then compare. So our first one is going to be 2/3. So what does that fraction look like again? What does the fraction look like, Allie? How do I write it? How do I write 2/3?
3 is the denominator.
That's right. That means the 2 is the numerator, right? And then how do I write 2/4?
And the 4 is the denominator.
That's right.
And the 2 is the numerator.
That's right. So now, which one's greater, guys? 2/3 or 2/4?
2/3.
That's right. So that means, in answer to the question, on which day did Ivan play the most basketball? Which day was it then? Which day did he play the most basketball? Who can give me a sentence? Wilkins?
He spent more time on Wednesday.
He spent more time doing what on Wednesday? Give me a complete sentence.
He spent more time playing basketball on Wednesday.
Who spent more time playing basketball on Wednesday?
Ivan spent more time playing basketball on Wednesday.
Good. Perfect. You guys have to get used to the restating. Ivan spent more time playing basketball on, wait, did you say Wednesday?
Yeah.
Ivan spent more time playing basketball on Tuesday. Tuesday, guys. Tuesday. 2/3. Ivan spent more time playing basketball on Tuesday. So any sentence that looks like that where you're restating, that's what I want to see. But Tuesday is the day you play 2/3, right? And 2/3 is greater than 2/4 because 2/4 is equivalent to what?
1/2.
That's right. Good. Now, number 14. On a trip to the beach, Josie collected 64 shells. I'm going to start doing some underlining, right? Physically, Josie collected 64 shells. Her father collected 57 shells. Her mother collected 73. The question is, this is important. How many shells did Josie's parents collect? Complete the bar diagram to solve. Now, we've been doing bar diagrams. We've done them several times this year, right? The question mark right here means that that's the number that you need to put right here. We just don't know the number yet. Now, we already know their mom's 73 shells and father's 57. Right here, 57's there. You can write the 73. You know it's 73. First question. What's our operation? Bruce, what's the operation?
Addition.
It's addition.
Trying to think of the word.
Yeah, that's right. It's addition. Now, do I have to add all three numbers, Allie?
No, you only have to add the father and the mother.
That's exactly right. So in this problem, is there some information we don't need? Yes?
And I know the answer.
Okay, good. So there's information we don't need, right? We don't need this stuff. So, Allie, so let's take this. And what was the answer? What'd you get?
130.
That's right, 130. Now, I know some of you do your addition differently, but the reason that I do mine like this is because it's very straightforward. Okay? 7 plus 3 is what? 7 plus 3 is what? 7 plus 3 is 10. Now you carry the 1. 5 plus 1 is what? 6. 6 plus 7 is what?
13.
That's right. So you get your 130. Then you put the 130 right there. That's it. There's a lot of words and a lot of information, but they gave you some you didn't need. Out.
I just added 3 and 7 together, then it made 12, and I knew my answer was 12. Then I put the 10 in. Then the 1 was the 100, and 2 was the 10.
I see what you're saying. You broke it apart a little bit, like kind of like how we did on some of our morning ones, right?
And then I added the 10.
Very good.
My answer is 2.
And then you got it. Are you sure? Do you need to sharpen? Go ahead. Good. So, Sellers, go ahead. And you can sharpen as soon as Brewer's done. Good. So, sometimes they give you information you don't need. That's why you have to read very carefully. Look at this math and science one. A plant's life has different stages. Leah measured the length of a seed. It was 1/4 inch long. She then planted the seed. It grew into a seedling that was 3/4 inches long. Use the fraction strips to compare the two fractions. So we're comparing again. And use the symbols, right? So here we go. So this is obviously the length of the seed right here, right? This is the seed. And this was her little seedling. So, which is greater, 1/4 or 3/4? Which one's greater, guys?
1/4.
Yeah, I don't know who said 1/4, but that's not going to make sense. 1/4 doesn't work. Look at the picture. 3/4. That's right. The seedling was obviously long. It grew quite a bit. In fact, it grew 3 times its size, right? Yes.
So I was doing this and I drew this because I did not see this at all.
Oh, so you drew, I see. You drew your own because you didn't see it. So you have to look carefully. Ah. Yes, please do. Okay. Now, I know some people got stuck on this one as well. Let's take a look. There are 4 people in Mitchell's family, 3 people in Paul's family. Each family buys the same size bag of trail mix to share equally. Who gets more trail mix, Mitchell or Paul? Use reasoning, and that's our question, right? Use reasoning about fraction size to explain how you know. So, we don't need to know exactly how big the bag was, do we? Because what we can do is we can take a fraction strip, right? We can draw it out one hole. And that can represent both families' bag, right? They bought the same bag of trail mix. But one family has 4 people and one family has 3 people. So what am I going to do? How can I draw fraction strips? How can I make it look something like this one over there? Use the same type of thing. How can I do that? Here. What do I need to draw? How many strips do I need to use? How many little squares do I need to draw for Mitchell's family? Allie? What do you think? And how many for Mitchell's?
4 Mitchell's.
That's right. So, let's say we drew 2 more of these. We could do it this way, right? Because we could say 1, 2, 3. Or we do 1, 2. Right? So this one could be Mitchell's family. This one could be Paul's family. And there are 4 people in Mitchell's. And there are 3 people in Paul's. So, looking at it like that, Andrew, I think you might have done something similar on yours, but you drew it out twice, but I drew it out 1 time. Who gets more? Mitchell or Paul? Who gets more trail mix? Because Paul's one of these 1/3, right? And Mitchell's one of those 1/4. So who gets more trail mix? That's right. Paul gets more trail mix. You see that, guys? Paul gets more trail mix because, bless you, there are fewer people in his family. And they don't have to divide up the trail mix as much, right? Because our comparison here, guys, what's our comparison here? What's our comparison? If you were looking at, because remember, Mitchell's 1 of 4, Paul is 1 of 3. Eston?
Okay, I got 2 questions.
2 questions.
What was the question?
What was the question again? This one? Well, first of all, we just determined that Paul gets more, right? But what fractions am I comparing? How do I know that Paul gets more? He does. He has fewer family members. That's right. Because Paul is 1 of 3 and Mitchell is 1 of 4, right? Oh, okay. But guys, what fractions am I comparing? If Mitchell is 1 of 4 and Paul is 1 of 3, what fractions am I comparing? Abigail? What fractions am I comparing here?
4 and 3.
Well, how many out of 4?
4.
Not 4 out of 4.
3.
Nope, not 3. Don't guess. John?
5.
No, 5. Where'd 5 come from? Guys, now you're just guessing. Ian?
1.
That's right. That's exactly right. Because Mitchell is 1 of 4 people, right? 4 people in his family. Paul is 1 of 3 people. So I'm comparing 1/4 to 3/4. Now, which is greater, 1/4 or 3/4? Which is greater? Andrew? No, which one of these fractions is greater? Which is the greater fraction? It's going to be 1/3. But see, you already knew that because Paul is that 1/3. If you have a bag of trail mix, remember both families bought the same bag, right? And you have to divide the bag into 4ths, you're going to have less per person, right? Am I correct on that one? Am I right? Thumbs up. And then that means that Paul, because he's in a family of 3 people, he's going to get more, right? And that means that Paul is that 1/3. Do you see what I mean? Paul is the numerator. He's the 1/3. His family is the denominator, the 3, right? Does that make sense, guys? So much questions?
2 things. If they buy that big cereal bag and pretend the cereal bag trail mix, there will be a lot.
Well, I'd say we could say we don't know how big the trail mix is.
Why did you get a leather thing?
Okay, so let's go ahead and take a look at the next one. Now, does that make sense, guys? I know that it looked confusing, but when you see it broken apart, does it make a little bit more sense? Jack says yes. It's okay if it doesn't, guys. Be honest with me. Tell me if it doesn't. If you're still a little bit questioning it, if it kind of makes sense. I got a lot of questions on this one. Kind of makes sense? Question, Andrew. Okay, go ahead. So get used to seeing these because you're going to see some of these, guys. Okay, everybody back in your chairs. Off the desks. Thank you. Bricks. Yes. So now we need to start. You know what I think we're going to start doing? Is I think every morning we're going to start going over our shapes again. Because we haven't done a whole lot of shapes yet this year, and you guys are going to need it because we're going to start doing some state test stuff very shortly. So on this one, circle the solid figure that has 2 flat surfaces and 0 vertices. What are they called? So there are 2 things you have to do here. Now, first, let me ask you, what's a vertex? What are vertices? What are they? Here.
They're like corners.
Yeah, so they're asking you for one that doesn't have any corners, right? And now they're also asking you for 2 flat surfaces. So, Andrew, which one am I circling? And which one is that?
Purple.
That's right. Now, if you guys remember, we also had cylinders and spelling work. So I know a lot of you were having Miss Paula look that up, and you should remember it because it was a spelling work.
I know, but you didn't understand.
That's right. This one can be confusing with the Y. We don't have a lot of words spelled like that in English. Sellers.
Could I do the next one, the Common Core assessment?
Okay, let's take a look at this one. These fractions refer to the same whole. Which of these comparisons are correct? Choose all. Guys, I cannot emphasize this enough, but some of you missed this on our last test. When it says you just choose all that apply, that means there is more than one answer. Very, very likely that there's more than one answer. Okay? You got to make sure that you look at every single one. When you see that word all, you have to look at every single one of them and test them and see if they're right. Okay? Hey guys, I'm seeing a lot of people doing other things. Abigail, whatever you're messing with, stop doing it. Okay? Well, you need to put them in a backpack or back in your ears then, because you're going to lose them and you're going to be sad. Guys, I need you guys to be focused. I know it's a Friday, but come on. You're all telling me this is easy stuff, so let's do it together. Let's get through it. Esther.
The first one and the second one.
Sellers. Same?
Yeah.
Well, let's take a look. So 3/4 does equal 3/4, correct? What about 1/6 and 1/4?
Nope.
Is 1/4 greater?
Yeah.
5/8 and 5/6?
No.
That was incorrect. 2/8, does that equal 2/3?
No.
And 4/8 and 4/6.
No.
That's right. You guys got it. Perfect.
Yes.
That one is pretty easy, right?
Very.
Good. Okay. Do I have questions? Listen, guys. I want you to know. I need you to ask questions. I need you to tell me if things don't make sense. Okay? I don't want you to sit around in the class and wait until we're working on it, put your hand up, and then wait for me to come over and do no work because you're confused and you could ask me. Believe me when I tell you this. Most of you, anybody who has a question in this class, most of you, it's very likely somebody else has that same question. They're just waiting for somebody else to ask it. So never be afraid to ask a question. Okay? And I'm not going to be disappointed if you don't get it. I want you to understand. That's what I'm here for, is to help you understand. Okay? So it doesn't help any of us if you guys tell me something you think I want to hear, like, oh yeah, I get it, it's amazing. Don't tell me that, it's not true. Okay? Be honest. We're going to try to make this work for everybody, okay?